Hello, I'm going to explain a very nice tool in the EM Viewer software that is called Scan Continuously. In my previous videos, I was using the scan mode. This is something like a single scan. So when you run the scan, you obtain a picture of the results. With Scan Continuously, what you get in the screen is something like a real-time result that is very useful when you are doing changes in the hardware or in the software of your device. In this way, it's very intuitive to see how these changes are affecting the emissions coming from the device. I am going to evaluate the emissions from this PC board with a microcontroller on top of the EMScanner. You can see here the top view of the experiment. And as in previous videos, the first step is to create the node you are interested in. For example, I'm going to create a spatial scan. We need to specify the frequency of interest. Let's introduce 11.06 megahertz. That is the frequency of the crystal, so it's the first harmonic of the microcontroller clock. The resolution bandwidth is 120 kilohertz. Then we need to specify what cells in my analysis will be active in the scanner. In my experiment, I will be activating the cells that are exactly below the device under test, in the position you can see in the screen. I'm going to introduce the Gerber file. We can rotate, we can mirror, and we can put exactly on top of the circuit. So we will have the possibility to identify the aggressive areas or the quiet areas that are below specific components, diodes, transistors, transformers, connectors, etc. So now we have finished the setup of the experiment and we are able to run the test. Let's start with a single scan experiment. In the single scan, remember, we will be scanning every of the cells I have activated at 11.06 megahertz. So in this way, the result that appears in the screen, let me make a zoom, is something like this, where we can identify in red color where 11.06 megahertz has a strong activity, and in blue color where the amplitude of this frequency is lower than some dBs below the red color. Now consider we want to make a change. What change? In my circuit, at this position, I have the possibility to introduce the decoupling capacitor. The decoupling capacitor of the microcontroller that now is not present. So you can see how big is the loop that the 11.06 megahertz signal is taking in the PCB. I'm going to run the test continuously. So at this moment, you will see how this red color is changing continuously, every second more or less, considering the time required by the software to run and the cameras to transmit the video. So let me remove the overlay so you can see better the effect. We can change the scale in colors, and it's very important to go to the scale option and unselect the auto scale amplitude box. Why? Because in this way, when we do the change in our circuit, it will be easier to compare without an automatic resize of the scale. So let's go to the circuit and let's introduce the small capacitor, the 100 nanofarad capacitor in place. So here is the position of the capacitor, and you can see how the red colors disappear. The colors are creating the effect that probably we have between 10 and 15 dBs less of activity in the PCB. It's more concentrated around the microcontroller. If we remove again the capacitor, you can see how again the red color appear, and additionally the green color go to the edge of the PC board. This is something that you can try in your designs with changes in your hardware, trying different components, for example, different values of capacitors, or for example, changing the software that is running in the microcontroller to see the effect in the emissions from your product. I hope you enjoyed the video and try it. It's very easy to do and it's funny. See you in a future video. Bye bye.